Okay, I'm going to go through how to use the BCOA-ME design procedure, but before we begin with that, I want to go through exactly what types of overlays we're talking about when we're using this design procedure. So traditionally these overlays were referred to as thin or ultra-thin white topping, which is just a bonded concrete overlay onto a distressed asphalt surface. And so this could be a single layer of asphalt that's distressed that you're placing your bonded concrete overlay on top of, or it could be a composite pavement where you have an overlay on top of your old concrete and now you're placing a new bonded layer on top of that. Typically the BCOA designs consist of overlays that are 3 to 5 inches thick. If you start getting a little bit thicker, 6 inches or more, you probably want to double check this with an alternative design procedure, because at this point the slab is getting sufficiently thick that it's carrying a large portion of load itself and it's not acting as much as a composite structure. For these overlays, we also, since they're so much thinner, we also use smaller slab sizes, traditionally 3 by 3 to 12 by 15 slab sizes. So now to go on to the BCOA-ME design guide itself and to walk you through how this procedure works. If you go to www.engineering.pitt.edu/vanderbush/BCOA-ME, you'll find the design guide, and if you're watching this video, you've probably already found it, and this is what that site looks like. So if you click on Design Guide, it takes you to the guide itself, and the first thing you want to look at is the general information that you're going to fill in. So what you need is a project location, and this is the longitude, latitude, and elevation. Now you can find this using a smartphone, the GPS in your car, or if you're doing the design in your office, there's a tool here where you can go and select your geographic information. And then you have two options. You can either go to a web page and type in the location of your project, find elevation, and then you have your information right there. You'll then have to cut and paste or type that information into your design sheet. The other option is to go into this drop-down menu, and you can go to the state that you're designing it in, and then the city that is closest but also represents the weather conditions at the project location that you're at. So here we are, Pittsburgh, Pennsylvania. We submit this, and if you do it this way, then this will automatically pull in the elevation, longitude, and latitude into your boxes for you. The next thing we're going to look at is traffic. So if you know your design easels, you can just type them in. If not, there's a tool to help you calculate them. And this is based on two different pieces of information that you might or might not have. So if you have the one-way ADT, you'd click on the yes, and then you'd enter in your inputs, such as terminal serviceability, number of lanes, percent trucks, growth of your ADT, whether that's growth can be linear or nonlinear, type of roadway you have, and then you hit submit and it'll calculate your easels for you. If you don't have the one-way ADT, you can also get a rough estimate based on the classification of your roadway. So typical distributions, which were established by ACPA, will be used to generate your easels. Okay, so once you have this information, you can hit submit. We're just going to enter in 1 million. Now, then we enter in our criteria. So the criteria is based on the percent slabs cracked. I would suggest that you maintain the 25% slabs cracked and 85% level of reliability. And this is because these are the values that we used in the calibration process. If you notice that these boxes, information boxes, keep coming up at the side, this gives you little information regarding the inputs. So next to each of your inputs, or a lot of the inputs, you'll have pieces of information that you can use to help you define those inputs. Okay, so we've defined our traffic, our location, our failure criteria, our reliability, and now we're going to go down to the climate. With our climate, we have two pieces of information that we want to define. And we can determine our average, mean, daily, annual temperature based on our climatic map. And again, if you need help, you can go to the right of your input box and it provides you with a little bit of information. So click on this blue writing and that sends you to the map. Now for each of these these areas where you're clicking onto a separate site, you can either click right on that site and it'll send you back to the design page, or you can click back. Either option works. So we're right here, Pittsburgh, Pennsylvania. This will be in our region 2. So then we either click on the map and it'll go back. Now when you click on the map or the zone, it doesn't automatically enter it in. You still have to manually enter in your region. Now we go to our zone for our sunshine. Again, it takes us back to the map, Pittsburgh, Pennsylvania. We're in zone 6. We can either click on the map and it'll send us back, or we can click on the back icon. But again, you must enter in the zone manually. Okay, now we're going to define the existing structure, the asphalt pavement that we are placing this overlay on top of. So the first thing we want to state is how much asphalt will remain after milling. And again, this is after milling thickness. So let's stick with 6 inches of asphalt after milling. Now we have to characterize the asphalt condition, and this helps us establish what the resilient modulus will be of the asphalt. Okay, so when you're establishing your composite K value, it's pretty straightforward if you just have a single layer of asphalt. So it's the combined stiffness of all of the layers below the asphalt layer. Now, if you have a composite pavement, you have 2 options. You have to determine whether this asphalt is bonded to the existing underlying concrete layer. Now, if it is bonded, then that's going to contribute to the stiffness of your asphalt. If it's unbonded, then when you're establishing your composite K value, you must include the stiffness of this existing concrete layer as well. So I'm going back to our design guide. If you need help in establishing your K value, you can go to the K value calculator, which takes you to the ACPA website. So here it is, and you can do this just as a single layer. So let's say we have a resilient modulus of 7,000, and that gives us a K value of 160. If we have multiple layers that we want to evaluate the composite stiffness of, then we can go into step 2 here, and it'll provide us with a way of doing that. Okay, so getting back to our design. Let's go with 150 as our composite K. Again, when we had a resilient modulus of 7,000, then it was about 160, so 150 will get us in the ballpark. And the next thing we need to look at is whether there's transverse cracking or thermal cracking within the asphalt. Now, if these thermal cracks are deteriorated, and again, if you can't quite remember what thermal cracks look like, this is what you have. If they're deteriorated to the point that aggregate from the concrete overlay can penetrate into the crack, then you want to do some type of repair before placing the overlay. But if it's not deteriorated, you do have the potential for reflective cracking under certain conditions. So you can account for the possibility that you might have reflective cracking by stating yes, we do or do not. And this is not going to affect the thickness of your overlay. It's just going to tell you if you might need to do something to mitigate cracks from reflecting from the asphalt layer up into your bonded overlay. Okay, so we've defined the existing structure. Now we need to define the properties in the concrete overlay. We can first define the strength looking at by entering either the 28-day 3-point bending or the compressive, and it'll then convert it internally to a fluxual strength. The elastic modulus of the concrete can be entered in directly, and again, this is a 28-day value, or you can use the calculator to do so, and then it's going to estimate it based on the strength they entered. The coefficient of thermal expansion you can either, again, enter directly, or you can calculate it based on the aggregate type that you have. Okay, now if you're going to include fibers in your overlay, you'll want to enter that here, and you'll have to define the type of fiber that you're going to use. If you do include fibers, you're also going to have to add the dosage rate. So, for example, you might add 25 pounds per cubic yard. Let's not use structural fibers for this design example. Okay, finally you need to design your joints. Here we'll go with a 6x6, but you'll see your options that you have here, and then you calculate your design thickness. So what it provides you is the thickness of the overlay. So here the actual thickness design was 3.64 inches, and you'd probably round that to 4 inches. Is there potential for reflective cracking for this type of a structure? Yes. So you probably want to do something to mitigate the potential for that, and there are several options that you can look into. This is how you use the BCOA-ME design procedure, and I hope that you'll take the opportunity to look through it and try it out. And if you do have any questions, you can go to the website where the procedure is, and there's also an opportunity to provide feedback.